What's up, everyone? Okay, we're going to move on to chapter 1.3. So up until now, we've been solving equations with, in kind of the form 2x plus 3 equals 12, where we have an x over here that we need to isolate. Hopefully we've gotten that down by now. If not, you can rewatch 1.2. But in this one, we're gonna have situations where there's an x on both sides. So for example, 2x plus 3 is equal to 7x minus 2. So we have to do something different with this. We can't just isolate the variable right away. Okay, that was definitely not my eraser. Okay, moving on. All right, so the key idea here, and this is something I want you to write down at the top. So solving equations with variables on both sides. I want this to be the title of the page, and I want you to go ahead and write this. So if you need to pause, go ahead. But the key here is that what we're going to do is we're going to collect all the variable terms. So we're going to collect the x's or the t's or whatever the variables are. We're going to do that first and put them on one side, and then put the constants or the numbers that are by themselves on the other side. So let's see what that looks like. Okay, so step one, we're going to rewrite our equation. So let's do that. Okay, now I need to get the variables together. So I'm going to have to move the negative 2x and over to where the negative 7x is. So you could move it the other way, but then you're going to end up with 0 on the other side. So this is if I add 2x, then I am doing the opposite of the minus 2x. So the inverse operation that I'm doing of minus 2x plus 2x, and I do that on both sides. Let's go ahead and draw our line to be consistent here. We have 15 is equal to, well, negative 7 plus 2 is negative 5x, and then negative 5x or negative 5 times x is what negative 5x means. So the opposite inverse operation of multiplication is division. So I'm going to divide both sides by negative 5, and that makes negative 5 over negative 5 gives us 1, which is what we want. We want to make 1x, and we end up with 15 divided by 5 is 3. 1 negative means it's negative 3. Okay. All right, so moving on, this one gets a little more challenging, but if you just, it looks scary, but it's not. So the first thing, all we're going to do here is we're going to do the distributive property. So if you remember how to do the distributive property, this is no problem. So again, we're going to rewrite our problem. I want you all to get in the habit of this. In fact, for this one, part of your homework, I want you to rewrite this exactly as I have. So hopefully your notes are out, and you can start writing this equation. Pause it if you need to catch up. All right, so we're going to distribute the 2 or multiply both terms inside the parentheses times 2, and then we're going to multiply both terms inside these parentheses by 6. So let's do that. We have negative 2x plus 10 is equal to 12 minus 6 times 0.5 is the same as half of 6, which is 3. Okay, and now we've got x's on both sides. So here comes a dilemma. Now that I've got x's and the constants on both sides, which one do I move? And what I try to do is I try to keep the x positive. So I'm going to add the 3x, because when I add 3x, keep the sign of the bigger number, I'm going to end up with a positive x, because then I don't have to deal with the negative x. So those go away. Let's draw our line, Mr. Hines. So we're left with 12 over here because our 3x's are gone. And negative 2 plus 3 gives me 1x. And we write 1x as x plus 10. And now I just need to subtract 10 from both sides. And 12 minus 10 is 2. Okay? Okay, so now we're going to talk about two exceptions to the rule here, okay? And that is equations that end up having no solution and equations that have what's called infinitely many solutions. So we'll start with the ones that have no solution here. They are, what happens is as you can see right here, I have added 4 to get rid of it. Well, when I add 4 there and I add 4 there, both of my x's go away. And I am left with this 3 equal to -7. Well, since 3 never will equal -7, so no matter what value I place in there for x, 0, 1, 2, 3, 4, 5, doesn't matter. Whatever I place in for x, the x's will cancel, and it will simply be 3 equals -7, which is never true. Therefore, there is no solution that makes this equal. Similarly, in this case, okay, I got a little bit more. You can kind of pause this and look at the equation, but we subtracted 6 down here from both sides, and now my x's are gone again. Only this time, 4 equals 4 is true. It is always true. No matter what value I put in for x and substitute it into this formula, they'll still go away, and 4 will equal 4. Which is always true, and therefore they say there's infinitely many solutions. So from negative infinity to positive infinity, you can put any number in for x. It will still get subtracted out right here, and you'll be left with 4 equals 4, which is always true. So that was kind of a weird one. Okay, so this is a really good example because this is a good kind of real, I wouldn't say real world, but a good example of how you can use an equation to solve something that's actually meaningful. Okay, so we're told that these two circles are identical. Identical means the same. So everything about them is the same. Their radius, their circumference, their diameter, everything's the same. So they're identical. So what is the area of each circle? Well, first of all, what is the radius of each circle? So the top one, our radius is x plus 2, okay? And if they're equal, then we're just gonna set it equal to the radius of this second one. Well, what's the radius of this circle? They give us a diameter, and radius is half of the diameter, right? So the radius is just this part. So what is half of 4x? It's 2x, right? So now we just solve. We subtract x, left with 2, and we're left with positive 1x over here. So x is equal to 2. All right, easy enough. Therefore, we need to find the area of the circle. So area of a circle is equal to pi r squared. Well, what's r? So pick either one of these, but I'll take this one because it's already the radius. So if I substitute in 2 for x, then I get 2 plus 2, which means that the radius is 4. So area is equal to pi times 4 squared. So therefore the area is, this is 16, 4 times 4, 16 pi, and I'm going to leave it in terms of pi. Okay, that looks like I just made a step one. So that should do it, and I hope you guys are doing well on this. If you have questions, you can always come see me in class or send me an email. Thanks a lot. And that's it. All right.